Just like measuring relative humidity, it can be tricky to measure the dew point. Scientists have to use a fancy machine that looks like this, called a dew point hygrometer. Basically, inside that canister, there's a laser shooting at a mirror, and they cool the mirror down to a temperature where dew starts to form on the mirror, blocking the laser. Whatever that temperature is, that's the dew point. So we can do a simplified version of that here in the lab. I have it set up over here in the side of the room. We have a metal can with water in it, and you see the temperature there in degrees Fahrenheit. What we're going to do is we're going to take an ice cube and put it inside the container, and that's going to make this cooler, and eventually dew will form on the outside of the glass. The temperature at which the dew forms on the outside of the glass will be the dew point. There we go. 43 degrees. Take a look. Have some sweat on the glass on the outside, right there. Okay. So this was the temperature at which dew formed on the outside of the glass. I put an ice cube inside, and that cooled off the temperature of the liquid inside the cup. The liquid's touching the cup, so therefore the metal cup got colder. The air just surrounding this cup also got colder, and eventually the air cooled to a temperature that when it hit the dew point, it became saturated, and that water had to go somewhere. And it had somewhere to go. It had this container right here, and it stuck to the side. So this is how a dew point hygrometer works, but instead of a cup, you've got yourself a mirror. So let's think about this in a fictitious way. There's my glass, and let's say I've had it sitting out just like we did here. Let's pretend that the dew point of the air in the room is 58 degrees. That's a measure of the moisture content in the room, remember. That's also the temperature at which the air will become saturated. Let's say our air temperature itself is 68 degrees, 10 degrees warmer than the dew point. So my room temperature water is going to be at 68 degrees. Now I want to cool down my drink, so I put some ice cubes inside, and that's going to lower the temperature of the cup. It's at 63 degrees, still above the dew point. Now my cup is at 58. It's now at the dew point temperature, so dew will form on the outside of the glass. You've probably noticed that taking a drink in the summertime. An ice-cooled glass will have dew on the outside, right up to the edge of the soda. Kind of like this cup here, where the condensation on the outside is only up to the level of the top of the liquid inside the cup. So dew point is the reason why we have dew form outside on the lawn, or sometimes on a windshield. Think about a nice field like this. We're going to do the exact same experiment, but now our cup is going to be flattened into grass. So let's say we have a dew point of 35 degrees. That's the dew point of the air, measuring the amount of moisture in the air. The grass is going to cool faster than the air does. So let's start the air temperature at 50 degrees, and we'll make the grass the same temperature because it's in the evening. Once the sun goes down, the temperature of the air is decreasing, but the temperature of the ground decreases quicker. So the air's at 46 and the ground's at 45. An hour later, the air's at 42 and the ground's at 40. An hour later, the air's at 38, but now the ground is at 35. The ground is at the dew point temperature, so now condensation is going to form right above that layer wherever it can stick to, and it's going to stick to the grass, and we're going to get dew. The coldest time of day is usually when you first wake up in the morning, when the sun rises. That's why you'll see dew out on the grass, usually in the morning. Once the sun comes up, the sun heats the ground. Once the ground goes above the dew point, the dew goes away. It evaporates. When the temperature and the dew point are below 32, then what's deposited is frozen. and we get frost. That's why the windshield gets frost overnight. The metal car or plastic car, the windshield cools faster than the air does. That glass gets to the dew point, water sticks to it, but it starts to freeze, and we get frost that you then have to, well, you're not going to scrape it off the leaves, but you have to scrape it off the windshield. Or you can turn on a defroster, blow some hot air onto the glass, warm the temperature of the glass above the dew point, and then the frost goes away. But usually I'm impatient. I start my windshield wipers and just wipe it away that way. Okay, the same thing happens out in a field. If the dew point, for example, is 30 degrees, then in this case, if the air is at 38 and the ground's at 35, nothing's going to happen. But as soon as the temperatures decrease for another hour, the air's at 34, the ground is at 30. Now we get frost on the ground. But let's take this problem one step further. What happens if the air temperature continues to decrease? Let's say it drops 4 more degrees in the next hour. Now the air is at 30, the ground is at 30, and lo and behold, the water in the air condenses on the closest object, usually dust in the air, and voila, you have fog. You've now made a cloud that's on the ground. So understanding the concept of dew point is understanding why clouds form. This is one of my favorite comics when I was growing up. It's by Gary Larson. It's called The Far Side, where these two pilots say, "What's a mountain goat doing way up here in a cloud bank?" Well, the mountain goat's not in a cloud bank. The mountain goat is on the mountain, and the mountain goat is in what it thinks is fog. But for the plane, it's flying through a cloud, and it's about to hit the mountain. Fog is a cloud that is on the ground. If you've ever wanted to know what it's like to be inside a cloud, just go outside when it's foggy. Fog is very, very common in low-hanging valleys, especially in the West Coast. This is the Great Central Valley in California, and you can see fog on the ground. It just looks like a cloud from satellite pictures. This is Golden Gate Bridge in San Francisco. You can see the tops of the buildings in the background, but this cloud has come in at the lower levels. If you're on the Golden Gate Bridge on the far end, you're driving in fog. If you are on the 15th or 16th story of one of those buildings in the background, you see nothing but fog outside. But go up to the observing platform on the 40th floor, and you're going to be looking down on the cloud. Fog is really, really common, and there's 3 basic ways that it can form. But it's always going to form with a difference of temperatures in mind. One of the temperatures is hitting the dew point. When we hit the dew point, fog forms. One way fog can form is having air being cooled to the dew point with no wind. Wind will simply mix up the air and blow the fog around. It will dissipate the fog and dry it out. When this happens, it's called a radiation fog. The sun eventually rises and heats the ground because the sun heats the ground. And the ground, once it gets above the dew point, causes the fog to go away. It evaporates. Some people will say the sun burns off the fog, but that's actually not how it happens. It dries out. Here's an example of some radiation fog around Penn State, and this is typically what we see here in Pennsylvania. This is actually a farm field in West Hempfield Township. And very low to the ground, very thin. The sun is just starting to rise, and there's a thin fog very close to the ground with the temperatures at the dew point. Some of the silos are even sticking up out of the fog. If it's colder than 32 degrees, this kind of fog can be quite dangerous because when it touches any object, it will instantly freeze. The supercooled water droplets freeze on things like this car antenna or on roads, so it can create black ice and dangerous travel conditions. A second way we can form fog is by adding moisture to the air. This happens in the city of San Francisco, where winds blow over the ocean and add moisture to the dry land, and it brings up the dew point and creates what's called an advection fog. We saw this picture before of San Francisco. You've probably experienced it if you take a hot shower. You add humidity to the air inside that room, and then you get a fog up on the mirror. This is an advection fog that has formed right over a creek that's snaking through State College, Pennsylvania. A third way we can make fog is something you've also experienced, just a big difference in temperature. For example, warm air sitting over fresh snow, or your warm breath going into cold air. Inside our mouths, there's a lot of moisture. It's very humid. The dew point is very high. When we blow that air out into cooler air, the temperature instantly hits the dew point and makes a cloud. But it doesn't take that long for that temperature to match and mix with the air outside, and it goes away. Well, this is known as a mixing fog, where we're mixing hot and cold together. Here's an extreme example from Yellowstone National Park. That water that you see there is 140 degrees. So 140 degree air just above it can hold more moisture, but as it hits the colder air surrounding it, it instantly creates a steam cloud. Geysers would form this as well. This is after a thunderstorm in the summer. It's hit the pavement, and now the air has cooled after the storm, and the wet pavement is quickly steaming, creating a mixing fog that goes away once the water dissipates. Some of the foggiest spots in our country are Cape Race, Newfoundland, where 43% of the year it's in fog because it's close to water. There's a lot of advection fog there. And I like some of these names. Cape Disappointment, Washington has over 2,500 hours of fog per year. Mistake Island in Maine is the foggy spot here on the East Coast. Mount Washington, New Hampshire has 300 days of fog a year. It's really not foggy, it's just that it's sticking up into the clouds. The clouds are always at the summit. So at the summit, you're reporting fog. Here's a map of North America, and you can see where fog tends to hang out in the Canadian Maritimes, in some parts of the Blue Ridge Parkway in Appalachia, and also in the Northwest Coast, and also coastal Alaska. And it can cause a lot of problems. One of our biggest car accidents that ever happened was back in 1990. 80 cars hit each other, 12 people were killed in Chattanooga, driving in fog. One of the worst boating accidents, the Andrea Doria, hit a tanker and killed 52 people in 1956. One of the worst plane incidents that ever happened. 2 jumbo jets collided in the Canary Islands in foggy conditions. And a dumb and useless fact, caribou in the Arctic tend to hang out with each other in big herds. Their breath forms a fog which hides them, called the caribou fog. And Inuit hunters actually look for that fog in the valleys and go down into it in order to hunt caribou. Now, one of Drew Anderson's students experienced what's called a chicken fog inside a chicken coop, and here's Drew to explain that.
So I have a video of something you rarely ever get to see. Inside, where there's a massive amount of chickens laying eggs. This is done commercially. There's over 100,000 chickens in this building. Each cage has 10 chickens in it. So let me explain why there was fog where all those chickens are. So to set the scene, it was one of those days where we had the polar vortex. So temperatures outside, they were just in the teens. Chickens, humans, we give off a lot of moisture. If you got 100,000 chickens in this room, well, there's a lot of moisture in the air. Dew points easily in the 70s, perhaps even in the 80s. It felt really humid when you walked inside there. So outside, we got dew points in the single digits. Inside, we have dew points in the 80s. So here's what's going on. That 80-degree air is hitting that 10-degree air that's coming in to help cool off some of that room. Well, that 80-degree air, it's cooling right past its dew point in the 70s down to, I don't know, we'll say in the 30s. When it goes from 80s and hits the dew point in the 70s, as it's getting cooled down, in comes the fog. And that's why we're seeing the fog. It had a lot to do with all the moisture in the air, but more so because that 80-degree air was getting cooled to its dew point. We only had to cool that air a couple degrees to reach the dew point. I think that is so cool. And the reason it's so foggy is because the air is so cold. It was able to cool enough of that 80-degree air to make it look like that inside.
As a weather forecaster, dew point and temperature help me figure out where the clouds are going to form and where the fog is going to form.